Welcome back, guys, and in this video we are going to continue our investigation of life series. We are going to expand the scope and coverage of what we look at to other planets in our solar system, and then even to other star systems in our galaxy. Now, just to recap kind of where we left off prior to this video, we started the series off with understanding and defining what life is. We talked about some of the players and architects that came up with our definition. It's a definition we are using, and NASA is the main contributor. We then looked at the biodiversity of life on Earth and all of its uniqueness and all of the classifications we have been able to identify. And we looked at grass as an example of how life replicates and evolves and adapts and releases its genetic information so that it can reproduce. Then we moved into understanding where did we come from? What was the anchor of where life that we observed began, and that was Luca, our last universal common ancestor, who coexisted alongside viruses. In fact, viruses likely predate Luca. So we did all of that, and then we ventured into understanding the very first structural formation that housed organic molecules, known as the protocell. And this protocell led to cells, and then Luca, and then us. And then lastly, we left off with abiogenesis. We looked at a few experiments that show abiogenesis is possible under the right conditions. In fact, it might even be likely given certain conditions, and those conditions we think are what the early Earth was like after its formation. So upon Earth's formation with our moon, we have life gets kicked off almost right away, which was shocking to me as I looked into this topic. Now we will go to the planets in our solar system, beginning with the closest planet to our star or sun, and that is Mercury. Now, Mercury, at the onset, I'm going to say it is unlikely that life exists as we understand it on Mercury. And that is because Mercury's temperatures are extraordinarily high during the day, and then they fluctuate to negative 180 degrees Celsius in just a few hours our time. Now, that fluctuation, no life form we understand can adapt to that sort of fluctuation. Not to mention even if it didn't fluctuate, the extreme temperatures of roughly 430 degrees Celsius at the temperature during the day would be too much for any biological organism we understand that has proteins, DNA. It would all denature at that temperature. In fact, in the laboratory, we can only get proteins to function at a maximum temperature of roughly 130 degrees Celsius. So that's nothing compared to 430. Now, we can't ever rule out the possibility that life might exist in some other form that is not DNA-based, that is not amino acid organic chemistry based, the way we have devised our models and how we see here on Earth. So we can never say it's zero, but we can set the probability extremely low for Mercury at roughly 10 to the negative 24 is what I have estimated it to be. Now, there are little pockets of area on Mercury that have ice water. These are permanently in the cold temperature range, which is negative 180 degrees Celsius. And that's because there's no atmosphere to trap any heat that it receives, or any radiation it receives from the sun. So just because there's water on the planet, it's not in its liquid form. It would not be able to metabolize anything like we have on Earth, given that nothing lives inside ice itself. So that's kind of a summary of Mercury and how I am thinking about life on Mercury. Now, you could always imagine, and I want you guys to imagine, life that exists beyond the confines of what we've put in place for our models of life. I am trying to do that, trying to think about what life could be like that's not organic chemistry, that's not carbon-based. And so I'll leave it there, and we'll move into Venus in the next episode.